Welcome to this new video where we will solve a very interesting problem. So we will build a RAG pipeline to ask question answer over complex PDF where we have tabular information also. So the idea is like from the tables which are present in a PDF, I want to ask some questions. We'll see whether we can get the right answers or not. This is always a very challenging problem, and we'll see how accurately we can solve it. So first we'll use LlamaParse here. So this is a new utility built by LlamaIndex, which helps us to extract the information, text plus the tabular information from the PDF, and it is working pretty good. It can extract most of the information correctly. So we will use LlamaParse as a PDF reader, which will extract the information, and we will use this uh, document, which is like Uber 2022 March quarterly report, which has lot of complex tables like this, big tables and all. So we'll ask different questions from these tables and under these different columns and see whether we can get the right answers or not. So let's get started. So for this, we are installing the required packages as we do always. Then there's some other packages also we need for this, so we are installing all them, and then I'm just downloading this PDF file using this command. And then to use LlamaParse, so recently like LlamaIndex launched their new cloud platform which they call Llama Cloud, and it has option of parsing also. So from here you have to create an API key, so this you can generate new API key from here, and that API key can be used to uh, use LlamaParse to query the extract information from the PDF. So what I'm doing is in Kaggle you have options on add-ons, so here you can save your secrets. I have saved my secret here, and I'm just reading that secret here using this command, and my secret value is stored here, which I will use later. Similarly, if you're using Google Colab, there also you have an option to store your secret key. So this is what I'm doing. Just go to this link, get your key and store your key safely somewhere so that you can use it later. Then I'm just importing all the required packages, and then I'm just installing my LLM model, the same Zephyr model from Hugging Face LLM, and I'm using the same embedding, which is BG small embedding, and I'm downloading using Hugging Face embedding. So this is my LlamaParse. I'm just importing LlamaParse, and to use LlamaParse you need to provide this key, then only you can use it as a API. So I'm just passing my key here, and I'm passing the path of the data, and it will just extract the documents into this documents variable. I'm just printing this, like how this extracted information looks like, so it looks good. So next what I'm doing is so to read this extracted information like the text and the table, I would be using markdown element node parser. So it will read my documents which has text and table and create different nodes. Now how it works, like it uses a large language model, and why it use LLM is to for the tables it creates summary also. So while extracting the text and the table information, it creates summary of the table and keeps a mapping of it. But I don't want to use summary. I will so without using summary also how good performance we can get. So it doesn't have an option, like user friendly option, to disable summary part and passing LLM as none. So what I have to do is that first I have to modify that class. So I'm just calling this markdown element node parser class, which calls this base element, like I added this base element node parser. So I have done some changes here in this base element node parser. First one is related to LLM. I just commented this piece of code. What is it just checks if LLM is there, then it uses LLM. If you pass none, it goes for OpenAI. I don't want to use OpenAI, so that's why what I've done is I've just commented this piece, and I'm just passing whatever value I'm passing into LLM. So if I pass none also, it will be passed into LLM as none, which goes in here. So that's one change I've done. Second, this is a function which creates a summary. I don't want to create a summary. So what I'm doing is in table output under summary variable, I'm just storing the table context, like the input text only I'm just passing as summary only. I don't want to call LLM and create the summary. It takes a lot of time to do that, so I'm avoiding it. And without this also it works pretty well. So these are the two changes I've done. Rest of the things is pretty well same. So I'm just calling this class which I modified here and passing LLM as none, number of workers. So it works as node parser, and then from node parser I can get nodes from document as we do always, by passing my extracted documents from using LlamaParse. It will create different nodes. Now what you have to do is like from node parser you have to call this get nodes and objects. So what it will do is like it will extract the text and the tables also. So text will be stored in base nodes and the tables will be stored in objects. So I just printed this table, one table, and you'll see this is how it's storing all the tabular information. And then what I'm doing, so I will be creating three different retrievers or three different strategies, and we'll see how all the three are performing and which one is working the best. So first one is I'm just creating a vector store index, and I'm passing in the nodes both the text node and the table node, like the objects and the base node, both I'm passing as nodes, and I'm creating a vector store index. That's one retriever we have defined. Second one is I'm just creating a new vector store, and I'm not passing any nodes and tables. I'm just passing the extracted document only, and it will just create chunks out of it by assuming tables as a text only, and it will create chunks, and we'll see how this also performs. And idea is to show like whether if we segregate text and tables separately in different nodes, will my performance improve or not. That's what we want to see. And the third one is the recursive retriever, the powerful retriever. So what I'm doing first, I'm just calling this node parser get base nodes and mappings. So it creates a mapping of the tables, and base nodes are stored in this. And then I'm just passing base nodes only into this vector store index, and which has a in mapping like ID of my tables which are stored in this, and recursive retriever will help with us to find that information from this node mappings. And then I'm just calling this index as retriever. I'm saying top case 15, and then in recursive retriever I'm just passing this index retriever which has the base node only, and then node mappings are the one which is there present here. So if for a given query, if we found an index node which has the ID of this table which is present in node mapping, so it will give me the table information, and that table will be passed to the large language model. So this is how recursive index will work. And then what I'm doing is I'm just using one more advanced technique which is re-rankers. So what I'm doing, I'm just taking top 15, like you've seen, I'm just taking top 15 as my context, but I don't want all top 15 directly to pass to my LLM. I want to re-rank them first and pass the top 5, and for that I'm using flag embedding re-ranker. And what it does, like it will take your query and every context, and it will pass that as an input to this BG re-ranker large model, and it will give me a score. So if you see, this is the link of this, like GitHub link, and of this re-ranker. So you just call this re-ranker and you pass your query in the passage is the context, and for every combination you get the score, and then it just gives you the top 5 scores combination. So same way we are doing here. So this is my re-ranker which I will use in all my 3 retrievers. So first one is the index with object, where the vector is store index, where I pass the node and the table together. I'm calling as a query engine, where top case 15, passing node post processor as re-ranker. So how it works is like it works as a node post processor. So first, based on the query, I will get the top 15 context, and then those top 15 contexts and the query combination, like query plus every context would be passed to this re-ranker, and all those 15 combination, and we'll get this score, and this based on this re-ranker I will get the top 5 which will be passed to my LLM. That's why we call node post processor. It's after getting the nodes we do post processing. So this is one query engine we have defined. The other query engine is using our raw index, which is my base one, which has all the documents. It doesn't know what are tables, what are text, and I'm calling as query engine top 15 here also, and I'm passing a node processor. Then the third one is our retriever query engine, which we using this recursive index. So I'm just importing this retriever query engine, which takes the retriever recursive retriever, and it also takes a node processor, and then verbose is false, and this is my recursive query engine. So these are the 3 query engines which we will be using to ask different questions from the tables, and we'll see whether we are getting the right answer or not, and which one is performing the best. So let's test all those 3 query engines. So we have our first question. The question is like, how is the cash paid for income taxes net of refunds from supplemental disclosures of cash flow information? So first, this query will go into my first raw query engine, which is the basic one, where it doesn't know what are the tables, what is text. I'm just passing complete document into vector store index. Second, my query will go into this index with object query engine, which has the index with table information. So this is a vector store index where I have pass text nodes also and table nodes separately as a combination. And third one is my recursive query engine, where I'm passing my text node into my vector store index and then the table nodes as part of mapping into this recursive retrieval. So for this question, let's see what answer we get. So from the first one, basic query engine, we got, so I just put a screenshot also. So like this was the question from this table, like income tax and net of refunds, like cash paid for, and the answer should be like $22 and $41. So if you see the first query engine, it got the correct answer, like 22 is 2021, and it was 41 in 2022, and this is the right answer. And from our second query engine also, we got the right information, 40, 22 and 41, and from recursive also we got the right information, 22 and 41. So for this question, all three retrievers query engine works pretty well. Now this is my second question, what is the change of free cash flow? So this is from this table I've asked what is free cash flow, and the answers would be like 682 and 47. So let's see what we got. So from basic query engine, what we got is like we got 47 and 682. So it fetched the right information, but I think the sentencing is not a free cash flow for the first quarter of 2020, which is a decrease of 682 million compared to the same period. I think the sentencing is not correct, it's not a decrease of. So we'll see how others are giving the answer. So for second one, I think it's not fetching the right answer. It fetched like 229 million and something and 15 million, which is not the right answer. So my second query engine is not working well. Let's see what we get from recursive. So from here we got the right information. So it just says free cash flow for the financial is decrease of 682 million for the first 3 months of 22 compared to decrease of 47 million for 21. So it got the answer correct also, and it interpreted also correct. Like this represented decrease of 635 million, but here it was saying it's a decrease of 680 something. So like basic found the answer right, but it could not interpret it correctly. But I think our recursive fetched correct information and it interpreted it correctly and gave us the percentage, like right percentage also, 93.5. So yeah, in this I think recursive works the best, and these two did not work well. So let's see the next question. So what is the net loss value to Uber compared to last year? So this is from this net loss attributable to Uber Technologies. So it should be like 5.9 billion and 108 million. So let's see what we get from first basic query engine. So it fetched the information correctly, like 5,918 million and net loss of 122. I think this is not right. I think it fetched this information 122, which is not as it should be 108. So I think yeah, basic did not work right for both. Let's see how my second one worked. So yeah, it gave 5.9 billion and 108. This is right. And recursive also it gave the right information. So yeah, these two work well for this. And this is my next question. What were cash flows like from investing activities? So let's see the temple. So yeah, cash flow from investing activity, and these are the sub activities, and the final cash flow is like 250 and 135. So this should be, so I think basic query engine just fetched the table only, it did not accept information. So till now I think basic is not working well. I think it worked well in only one question. Let's see how this second one worked. So it's giving me 135 million, primarily consisting of 60 billion purchase of 55. I think it's giving the breakup also. And net cash use was 250 million, primarily consisting of 803 million in purchase of 336 million, like this. So yeah, it's giving very detailed answer, not up, like not specific to this question. It's what we asked. But if you see recursive, it's giving according to the given context. So the cash flows for investing activity for first 3 months in 2021 were negative with a net cash of 250, which is this one, and 22 the net is 135. You can see recursive retrieval is working well for this question also. It fetched 250 and 135 answers correctly. So in all the 4 questions, I think recursive retrieval is working the best. It's not only extracting the information for a given question, but it's framing the answer very well. Otherwise, the other retrievers, sometimes they're not able to get the right answer. Sometimes they're not able to frame the answers correctly. So yeah, if you use LlamaParse with this recursive retrieval engine, the way I've designed it without the summary and using open source Zephyr model, I think you can get the best result in any of the complex PDF. So yeah, that's all for today. Thank you for watching the video. Please do subscribe and share your feedback. Thank you.